Hello, my name is Camille Quick, and this is my Physics Lab 2 report. In this lab, I will be focusing on calculating the charge of a piece of tape modeled as a uniformly charged rod and showing an electric field due to a larger number of point charges. If you can recall from the last lab, I treated both tapes as individual point charges, and these are the important concepts from that. In this lab, the tapes are modeled as uniformly charged rods made up of 10 point charges. At every point charge, there is an electric field produced on the top tape by the collection of point charges on the bottom tape. To find the electric field, you sum together the electric fields produced due to each point charge. To find the total charge of the rod, you start by calculating the electric field vector of the far left bottom point charge at each observation location of the top tape to get an electric field produced by the far left bottom point charge that acts on the far left top point charge. This is repeated for every source location of the bottom tape. Then add all of those electric field vectors together to get the net electric field of the bottom tape acting on the top tape. To find the charge, which will later be seen in my code, you test several Q or charged values to multiply by the calculated electric field in order to get the electric force to equal the gravitational force to satisfy Newton's second law. Some assumptions I made were to ignore air resistance on the tapes, to ignore the intermolecular interactions between the point charges within each separate tape, to treat each long tape as though it were a uniformly charged thin rod with the charge evenly distributed along the tape, and lastly, to assume that each tape had the same amount of charge like in the last lab. In Lab 1, I found the amount of charge needed to float a piece of tape. To do that, I found these important values. Here in Lab 1's computational model, we see the tapes being modeled as point charges and that the electric field from one point charge on the bottom is acting on the point charge on the top. In this lab's model, however, we see that each bottom point charge has an electric field acting on each top point charge to ultimately create a positive net electric force acting on the top tape. The magnitude of the charge on one piece of tape is negative 8.4661 times 10 to the negative 9 coulombs and was formed by plugging in different charged values into the code to get the magnitude of the electric force to equal the gravitational force. In conclusion, when finding electric fields of distributed charges, you must divide the charged object into pieces, find the electric field due to one piece, and then sum the electric fields of all pieces. A better estimated or more accurate value can be found by sectioning the rod into more pieces. The main question to be answered is why my values of charge for the point charge and the line charge differ, and it is because with multiple point charges you have multiple electric fields being produced. The real value would be closer to a line charge because the tape has a length of L. Thank you for watching.